Welcome to the module Metaphysics. This is the first lecture of the term, and I'll be seeing some of you at least in seminars as the term goes on. So this week we're going to just start with some module preliminaries, and then we're going to move on to our first topic, which concerns identity. So I'll be using slides. The slides are available on Moodle. I'll also have them up on the screen here so that hopefully you can follow along. But I'll sort of speak whilst you're viewing the slides rather than me. So I'll just pull them up there. So identity, and specifically identity through time, is our topic for this week. But first of all, I'd just like to go over some course preliminaries that you may already know, but I think will be helpful to at least some of you. So as it says on the course Moodle site, obviously if you're viewing this, then you've managed to access that. The themes, the sort of broad themes of the module are the central metaphysical topics of change and identity. So obviously we're starting with that this week. We'll talk about possibility and necessity, causation, and then finally about time and space. So these are really central topics in analytic metaphysics. And so it'll be certainly going forward with your studies, it'll be helpful to have a good background in these. The sort of key book that we'll be using, we'll be drawing upon articles too, and chapters from other books, but a sort of, if you like, a textbook for the course is this one by Jonathan Lowe, called A Survey of Metaphysics. There are copies available of this via the library, UCL library. It might be a good idea to purchase one for yourself, just so you've got a paper copy yourself, just because there's likely to be some demand on the library copies. You can get it via Amazon and so on, and it's not too expensive. Okay, so you'll be divided up into various seminar groups. If you go to the UCL common timetable, so there's a link from the slide, which is on Moodle, then you should be able to log in and go to your personal timetable, and that should give you both the time and the location of your seminar group. And obviously there'll be one seminar per week for each group, and these will follow the lecture. It would be a good idea each week if you could do the reading, at least the key reading listed on Moodle for each topic prior to that week's seminar, indeed prior to that week's lecture. Then you attend the seminar. If you do the reading first, then you'll have a better idea of what's going on, and you'll get more out of the lecture and the seminar. So the key readings for each week are listed again on Moodle. In most cases, there are also some further readings, which you're not necessarily expected to do prior to the lecture, but are really there so that if you decide to write a summative essay on a given topic, you've got them there for further assistance with your essay writing. Make sure you check Moodle regularly during the term. It will be updated. Things like lecture slides and handouts and so on will appear there as term goes on. It's good, I guess, to have a sense of what the assessment for the module is right from the get-go. So the assessment's via a 2,500 word essay, so reasonably standard for the philosophy department. This summative essay is due on the first day of term 3 at 4 p.m. And in addition to that, you'll have the opportunity to write a formative essay. So the formative essay is just a practice essay, just for feedback. Doesn't count towards your grade. It's not a course requirement. Strictly, it's optional. Though you're encouraged to complete a formative essay in order to get feedback that will hopefully help you to write a better summative essay. So whilst the summative essay is 2,500 words, the formative essay is a shorter version, 1,500 words. and this will be emailed to your seminar group leader. So different students will have different seminar group leaders. The seminar group leader will be the one who principally marks the piece. So email the formative essay to your seminar group leader by 4 p.m. on the Monday following reading week, and then you'll get feedback in good time to complete your summative essay. Summative essays, by the way, are not emailed to us, but rather they're submitted via a link that will appear on the Moodle course page. The essay questions for both the formative and summative essays are already available on Moodle. So I like to set them early in term so that you've got plenty of time to think about what topic you'd like to write an essay on, think about how you construct that essay, and you to start with the planning and writing in good time. So there's no sort of not too much panic or stress towards the end of the module and towards the deadline for the essay. So you should answer one question for the formative essay and one question for the summative essay. But importantly, if you like, you can write on the same question for both the formative and the summative essay. So you don't have to, but you can, if you want, write on literally the same question for both essays. And so the idea there is that, if you want, then you can get feedback on a kind of short essay, the formative essay, that will then hopefully be expanded and improved into the summative essay. So the feedback there would hopefully have very direct relevance to your summative essay. So if that's an approach that you like, then you're perfectly at liberty to do that. And there's no, in terms of reproducing material from the formative to the summative essay, that's absolutely fine. If you like, you can literally copy paste, and that's not self-plagiarism, because it's internal to this module. However, obviously, it's sort of expected that the summative essay wouldn't simply be just a reproduction of the formative essay, but it would be a sort of expanded, improved version. So just general advice to start planning and writing early as well. So obviously, many of you will have a number of assessments following the Easter break, either essays due in immediately following the Easter break or exams in term 3. So given that you've got the access to the essay questions very early on in this module, it might be a good idea to start thinking about what you'll write on, planning for that, and writing reasonably early on, so that you obviously are able to sort of manage your time better going into term 3. Okay, so that's enough for the course preliminaries. Obviously, if anyone has any questions, then please do email me, and I will do my best to answer them. So also you can come to my office hours, which are available on the course website. I should say, by the way, just in case it wasn't obvious, that seminars and office hours will be in person this term. It's just the lectures that are online. Okay. So this week's topic, as I said, is identity and change, and a kind of thorny metaphysical question, which is, to put it very broadly, how identity can be reconciled with change. That is, how and whether objects can continue to exist, can persist, even though they change over time. So I suppose maybe a nice example would be take these photos of Ian McKellen, the famous Shakespearean actor who was also in Lord of the Rings. On the left of the slide is a photo of Ian McKellen around 1961. And on the right is a photo of Ian McKellen about 60 years later, so roughly the present day, recent photo. Now, it should be obvious that although I'm saying that these are two photos of the same person, namely Ian McKellen, nevertheless, the sort of subject of the photos, if you like, seem to differ in their characteristics and their properties. So on the left, we see young Ian McKellen. He has, for instance, dark hair. Looks like he doesn't have wrinkles, many, if any, wrinkles. He doesn't have a beard and so on. Whereas older Ian McKellen has white hair, is quite wrinkled, has a beard. There are other properties that they differ in. For instance, what they're wearing, maybe also certain relational properties. So where they're located, it might be that I'm sort of making this up, but it might be that young Ian McKellen lived in Oxford, whereas old Ian McKellen lives in London, for instance. So different relational properties as well as different intrinsic properties. So the intrinsic properties are, roughly speaking, the ones that you can tell an object has just by looking at it. So in the case of the person, Ian McKellen, I can tell just by looking at him whether he's dark-haired or white-haired. So that would be an example of an intrinsic property. On the other hand, a relational property, you might not be able to tell just from looking at an object whether it has that relational property because it's a relation to another object. So, for instance, if old Ian McKellen lives in London, that's a relationship, the lives-in relationship between Ian McKellen and London. So that's a relational property. So generally speaking, we would expect at least some of the intrinsic and also some of the relational properties of any given object, for instance, a person, to change over time. So the big picture question is going to be, how is it possible that an object retains its identity over time? That is to say, the subjects of the two photos are one and the same person, namely Ian McKellen, despite this change both in intrinsic and in relational properties. So before sort of tackling that question head on, it's going to be useful to make a couple of preliminary distinctions, just to sort of help frame the question as clearly as possible before tackling it. So these preliminary distinctions are going to be, on the one hand, a distinction that philosophers sometimes draw between what's known as qualitative identity and numerical identity. On the other hand, between two sorts of identity claims, diachronic identity claims and synchronic identity claims. So we'll start with qualitative versus numerical identity first. So I guess this corresponds to two ways in which it seems that the word identical is used in ordinary language. Sometimes when we say that one thing is identical to another, we mean it's qualitatively identical, and sometimes we mean it's numerically identical. So what is qualitative identity? Well, two things are said to be qualitatively identical if they share all of their intrinsic, that is non-relational properties. If you recall, I just distinguished between intrinsic and relational or extrinsic properties. So, as I said, intrinsic properties, roughly speaking, the ones that you can discern just by looking at an object, just by considering that object on its own. So things perhaps like shape and colour and size. So, for instance, Ian McKellen's hair colour was something that was an intrinsic property, something that you could tell just by looking at him. On the other hand, there are the relational properties, so the relations an object bears to other objects that can't necessarily be discerned just by looking at that single object in isolation. So relational properties will include things like is taller than, is the son of, is within 3 miles of. So, it might be that young Ian McKellen was, maybe when that photo was taken, I don't know if this is true, but just suppose he was within 3 miles of Christchurch College, Oxford, when the photo was taken. But old Ian McKellen, we're supposing, is in London, is not within 3 miles of Christchurch College, Oxford, so has different relational properties to young Ian McKellen. Okay, so hopefully that intrinsic and relational distinction is roughly clear, at least a first approximation. So the idea then with qualitative identity is that two things are qualitatively identical if they share all of their intrinsic properties, the non-relational properties. So, for instance, I guess a sort of well-known case of this is identical twins, right? So we say that a pair of twins is identical. So I don't know if any of you have ever seen this movie from, I think it was like the late 80s or early 90s, called Twins, starring Arnold Schwarzenegger and Danny DeVito. So obviously the joke, insofar as it's funny, is that Arnold Schwarzenegger and Danny DeVito look nothing alike, so this is a case of non-identical twins. But in the case of genuinely identical twins, the idea is that they are going to be indiscernible in their intrinsic properties. So identical twins would, unlike these two, be the same height, same hair color, and so on. Another example, so we talk about identical twins. What we're saying is they're qualitatively identical. Another example of qualitative identity might be between two cars, right? So we might say that two cars are identical if they, for instance, are the same make and model, they're the same year, they're the same, well, maybe year's relational, I don't know. They're the same color and so on. Numerical identity, on the other hand, is different from qualitative identity. So when we say that object A is numerically identical to object B, we don't simply mean that A is exactly similar to B. So in the case of identical twins, what we mean by saying they're identical is that they're exactly similar, at least in their intrinsic respects. But when we talk about numerical identity, we mean actually we're not talking about two objects at all, but we're talking about one and the same object, literally the same object. So if you try to sort of characterize this, maybe in terms of a sort of formal definition, I guess a stab might be to say that numerical identity is the relation that everything bears to itself and nothing else. Well, it turns out that won't quite do, because it's true that numerical identity is a relation that everything bears to itself and nothing else, but perhaps there are other relations like that. But the essential point is that when we say that numerically identical, we're saying, look, there's just one object here rather than two. Obviously, if we talk about identical twins, we don't mean there's literally one object, that the objects are, if you like, literally identical. The people are literally identical. We mean that just that they're exactly alike. We don't mean that actually there are not two people but just one person. Rather, we're saying there are two people who are exactly alike intrinsically. And likewise, if I say that my car is identical to yours, then probably I don't mean that there is only one car that we share between us, but rather I mean they're exactly alike. They're alike in their qualitative or intrinsic respect. So when we talk about identical cars, identical twins, we talk about qualitative identity. Numerical identity is to say that there really aren't two objects or multiple objects, so there's only one object. So to put it a bit more formally, A is numerically identical to B if and only if A and B are literally the same object. So A and B could just be two names for the same object, for instance. So an example of numerical identity would be the relationship between George Orwell, the famous author, and Eric Blair. So George Orwell was a pen name for Eric Blair. They were literally the same person, just going by different names. So here, obviously, we don't have twins. We have one and the same person. So this is a case of numerical identity rather than mere qualitative identity. Maybe a slightly more contemporary example: Stormzy and Michael Amari. Stormzy is a stage name for Michael Amari. Again, we're not dealing with twins here. We're not dealing with mere qualitative identity, but rather numerical identity. Stormzy and Michael Amari are literally one and the same person. So just to be clear, when we're talking about numerical identity, so this could be considered sort of proper identity, at least unless I say otherwise. When I talk about identity, I'm going to mean proper identity, that is numerical identity, when we have literally one and the same object. And when I wish to distinguish, I will explicitly say qualitative identity. Okay, so I said that qualitatively identical objects are exactly like their intrinsic properties, but they might differ in their relational properties. So, for instance, if I have a qualitatively identical car to you, then that presumably means they're the same make and model, they're the same color, and so on. So they share their intrinsic properties, but nevertheless, presumably they're going to have at least some differing relational properties. So, for instance, my car might be parked in my driveway, whereas your car might be parked in your driveway. So they have different spatial relations to things. My car, I suppose, bears a spatial relation of being parked into my driveway, but not to your driveway, and your car bears the spatial relation being parked into your driveway, but not to my driveway. Likewise, if we considered identical twins, it might be that one of them lives in London, the other lives in Paris. So although they're qualitatively identical, they're identical in their intrinsic properties. They bear different spatial relations to objects like the Eiffel Tower or Big Ben. However, we'd expect that numerically identical objects are exactly alike, both in their intrinsic properties and in their relational properties. And as we'll see, this is a principle that's known as Leibniz's law. We'll return to this later on after the philosopher. Now, so for instance, if we consider Stormzy, Michael Amari, so it's not just the case that Michael Amari and Stormzy are alike in all their intrinsic properties, so same height, same weight, same skin color, same hair color, and so on. But we'd expect, of course, being one and the same person, for them to be alike in all their relational properties too. So, for instance, if Michael Amari is in London, then surely Stormzy's got to be in London too, because after all, they're one and the same numerically identical person. So, would expect numerically identical objects, as the slide says, to be exactly alike, not only in their intrinsic properties, but also in their relational properties too. So yeah, as I said, we could consider numerical identity to be sort of true identity when we really mean there's only one object, and it's when hereafter I simply speak of identity, I'll mean numerical identity unless I say otherwise. And normally that's the case in the literature. that when people simply talk about identity, what they mean is numerical identity, strict identity. Okay, so a second useful distinction is one that might be made between two sorts of claims about identity. So synchronic claims about identity and diachronic claims about identity. So a diachronic identity claim is one that asserts that some entity, call it A, that exists at one time is identical to some entity B that exists at a different time. So diachronic just means across time or between two times. So diachronic identity claims are assertions that an object is identical over time. So we've already sort of met one instance of this. So if I say, look, it's the same person depicted in this photo from 1961 as in that photo on the right from 2022, maybe realistically 2021 or something, then it seems that I'm making a diachronic identity claim. I'm claiming that a person that I'm taking to exist in 1961, being the subject of the photo on the left, is literally the same person, is a numerically identical person to the person that exists in 2022 and is depicted in the photo on the right. So I'm saying these are both Ian McKellen, right? These are both photos of the same person, namely Ian McKellen. So I seem to be claiming that there's one and the same person here, but photos of him taken at different times. Nevertheless, this person retains their numerical identity across time. So that would be a diachronic identity claim. On the other hand, a synchronic identity claim is a claim that an object A that exists at one time is identical to an object B existing at the same time. So they're not really cross-time claims, or maybe they're sort of atemporal claims. So for instance, if I say Stormzy is identical to Michael Amari, I'm not really making a cross-time particularly identity claim. I'm making a claim about simply that doesn't reference time, about maybe a person supposed to exist now with another person supposed to exist now, and just saying, look, these supposedly two people, or there's a really one person going by two different names. So the synchronic would be either a claim about identity at one and the same time, or maybe an atemporal identity claim, one that doesn't mention time, whereas a diachronic identity claim would be a claim that some object or person retains their numerical identity across a stretch of time. Okay, so that in terms of preliminary distinctions, I think will do us. Now, I've said that sort of principally we're going to be concerned with numerical identity or identity proper. What we'll see is that diachronic identity claims are, particularly philosophically sort of problematic or interesting, and they'll be our principal focus rather than synchronic identity claims. But just sort of, I suppose, first of all, it's kind of worth, again, in a slightly preliminary way, to mention a few important properties of the identity, the numerical identity relation. So it has some widely agreed upon formal or logical properties. So first of all, it's reflexive. That is to say, so a relation is reflexive if for any object X, X bears that relation to X, to itself. So identity is one such reflexive relation. So everything, of course, is identical to itself. All objects bear the identity relation to themselves. That hopefully is fairly uncontroversial. I formalized this in the terms of first order logic. So that may or may not be helpful to you if you studied first order logic. I guess most of the philosophers would have done in their first year. Then that will be at least somewhat meaningful to you. If you haven't, there's no need to worry. It's only there in case it helps you. So reflexivity for all X, X is identical to X, is the formalism stated under one. Symmetry is a second important formalogical property of identity. So again, hopefully this seems fairly bland and obvious. It's supposed to. It's supposed to be a platitude. So symmetry is, I guess in general, a relation is symmetric if and only if for all X and all Y, if X bears the relation to Y, then Y also bears the relation to X. Identity again is such a relation. So obviously, it seems obvious to me at least, and hopefully it seems obvious to you, that if X is identical to Y, then Y is also identical to X. So formally, for all X and all Y, this formalism says if X is identical to Y, then Y is identical to X. Again, hopefully fairly obvious. And then thirdly, transitivity. So I should say, although these properties seem fairly obvious, they're sort of important or appealed to in debates about identity and diachronic identity. So they're sort of worth kind of remembering. Transitivity. So in general terms, transitivity says that a relation is transitive in general if and only if A bears that relation to B and B bears that relation to C, then A bears that relation to C. So to put it specifically in terms of identity, if actually I've used X here, if X is identical to Y and Y is identical to Z, then X is identical to Z. So the formalism just says for all X, for all Y, and for all Z, if X is identical to Y and Y is identical to Z, then X is identical to Z. So transitivity, slightly more complex, but hopefully should be fairly intuitive. Actually interesting, it's a sort of relation that we'll talk about a bit later in term when we talk about causation too, because there's a question about whether causation is transitive. Identity, I think, is pretty much uncontroversially taken to be transitive. So reflexivity, all objects are self-identical, so that includes people like the musician Prince. So Prince is identical to Prince. Okay, so hopefully fairly obvious. Symmetry. So I'm using Prince because he was quite famous for changing his stage name quite a lot over time. So he started off being known as Prince. I think that was the first stage name he had. And then I guess he stopped using the name Prince, and people used to refer to him as the artist formerly known as Prince. So symmetry could be illustrated by pointing out that obviously if Prince is identical to the artist formerly known as Prince, then the artist formerly known as Prince is identical to Prince, right? So we could have done it with George Orwell and Eric Blair alternatively. So if George Orwell is identical to Eric Blair, then Eric Blair is identical to George Orwell. Transitivity, so Prince became known as the artist formerly known as Prince, and at some stage adopted this symbol as his name. So I think this is supposed to be a love symbol. I think maybe he invented it. I'm not sure. So transitivity would imply that if Prince is identical to the artist formerly known as Prince, and the artist formerly known as Prince is identical to the guy known as love symbol, then Prince is identical to the guy known as love symbol. So that would illustrate transitivity. Okay, so we've got these three formal or logical properties: reflexivity, symmetry, and transitivity. And there's an important principle that concerns numerical identity, but is maybe a more substantive principle than the ones that we've considered so far, and potentially a little bit more controversial. So we're going to treat it more as a metaphysical principle than a mere formal logical principle. And that is Leibniz's law, the indiscernibility of identicals. So it's something that we encountered earlier on in this lecture, which says that if X is identical to Y, then X and Y have exactly the same properties. So both intrinsic and relational properties, because we're talking about numerical identity here. So I say, maybe this is a bit more sort of a substantive principle than a sort of bare logical principle. But hopefully it sort of still strikes you as fairly intuitive. Most philosophers seem to agree that it's true. We already sort of considered, the case of Stormzy and Michael Amari, and the case of George Orwell and Eric Blair, right? So if they're literally identical, if they're numerically identical, one and the same person, then it seems that they must have exactly the same properties, both intrinsic and relational properties. So if Stormzy's in London, then Michael Amari's got to be in London too. If Stormzy is, 6'3", then Michael Amari's also got to be 6'3", and so on. For those of you, don't worry if you haven't, but for those of you who have studied formal logic, first order logic, then this principle of indiscernibility of identicals is the principle that justifies the so-called identity elimination rule in first order logic. Basically, that rule says that if you know that object A has some property P, and you know that object B is identical to object A, then you can infer that object B also has property P, which seems reasonable enough, no matter what that property, whether it's a relational property or an intrinsic property. Okay, so as I say, don't worry about that if you did not study first order logic. It's just a point of interest, I suppose, for those who did. And so it's also sort of interesting that, although this might be considered a sort of reasonably substantive metaphysical principle, it is one that is sort of assumed so widely that it's taken as fairly unproblematic to have it underwrite an important rule that we use in philosophy when we do formal logic. Okay, so with all of this in hand, we're better able to frame the specific problem of what we might call diachronic numerical identity, so cross-time identity in the strict sense. And, it may well have already occurred to you, this problem. Indeed, we sort of already kind of hinted at it, at least, when considering the Ian McKellen case. And what I'm going to do in the rest of this lecture is just sort of say what the problem is, because it will be next week's task to look at solutions to this problem, the various philosophical solutions that have been suggested in the literature. So it's enough to state the problem for now. And this is that what I've said on the slide, called on the slide IOI, the indiscernibility of identicals, leads to trouble regarding diachronic identity claims, specifically numerical proper identity claims. So, to use this same example again, in saying that the person depicted on the left is the same person as the one depicted on the right, namely, they're both depictions of the actor Ian McKellen, I'm making this diachronic numerical identity claim. I'm saying that this person existed over time in order to be the subject of both of these photographs, and that, it's literally one and the same person. There's not two different people, but one person, namely Ian McKellen. Now, hopefully it should be reasonably obvious why this seems to be in tension with Leibniz's law, the indiscernibility of identicals, because Leibniz's law says that if A and B are identical, then A and B have all the same properties, both intrinsic and relational. However, it just seems not to be the case, at least on the face of it, that the person depicted or the subject of the photo on the left has the same properties as the subject of the person depicted on the right. So, as I've already said, for instance, if we consider intrinsic properties, the subject of the photo on the left has dark hair, the subject of the photo on the right has white hair, the subject of the photo on the left is unwrinkled and has no beard, and so on. The subject of the photo on the right is wrinkled and has a beard. So it seems that the subject of the photo on the left differs, certainly in terms of intrinsic properties, from the subject of the photo on the right. Also, I suggested that it's plausible that the subject of the photo on the left also differs in relational properties from the subject of the photo on the right. For instance, it might be that young Ian McKellen lived in one place and old Ian McKellen lives in another place. So the question is, given this difference in properties, how can we reconcile this with the claim that this is just the same person at different times, where same is taken to mean numerically identical? Doesn't this identity, despite difference in properties, just directly contradict Leibniz's law, which seemed to be an intuitive principle concerning identity? So this is the sort of central problem that we're going to turn our attention to. Sometimes it's called the problem of change. So the problem of how something, one and the same thing, can change, right? So how can it be one and the same thing even though it changes in its properties? Given the intuitive pull of Leibniz's law, which of course says that if A is identical to B, then A and B have to have all the same properties. Sometimes, on the other hand, as I've said, sometimes it's known as the problem of change. Sometimes, and I think rather misleadingly, it's called the problem of temporary intrinsic. So you'll see a lot of reference to the problem by this name in the literature. So the idea is that we've got a problem because objects change in their intrinsic properties over time, right? And this seems to be in conflict with Leibniz's law. They change in their intrinsic properties so that their intrinsic properties are temporary. That's why it's known as the problem of temporary intrinsics. But actually, this is somewhat misleading, I think, because it doesn't really have anything particularly to do with intrinsic properties. So, as we've seen, objects also appear to change in their relational properties over time. And this seems just as much of a problem as their change in intrinsic properties over time, in view of Leibniz's law, because Leibniz's law implies that if A is identical to B, then A and B share all of their intrinsic properties, but also all of their relational properties. So I take this term to problem of temporary intrinsics to be slightly misleading, because the problem has nothing specifically to do with intrinsic properties, but applies just as well to relational properties. Nevertheless, it's widely used in the literature, so we can use it as long as we bear that in mind. Okay, so I mean this sort of repeats. Actually, no, it doesn't repeat what I've said already. It's sort of anticipating what's to come in next week's topic. So basically, what we'll see is that most philosophers. So we're faced with this problem of diachronic identity, the problem of change. What we'll see is that most philosophers try to argue that indeed the person called Ian McKellen now is numerically identical to a person called Ian McKellen who existed in 1961. So they normally try to retain what might strike you as the common sense view that we're not dealing with two people here, but only one person, Ian McKellen. But given that they don't simply reject this common sense identity claim, obviously the challenge is to tell us what gives instead of the identity claim. So do we simply reject Leibniz's law? And if so, how do we explain why it seems so plausible to us? Or do we try and come up with some sort of fancy way of maintaining Leibniz's law, and arguing that in fact Leibniz's law is not, as it appears, incompatible with the claim that Ian McKellen now is identical to this person, Ian McKellen, who existed in 1961. So, just to anticipate, most philosophers or most philosophical attempts to get to grips with this problem have tried actually to sort of have their cake and eat it. So they've tried to endorse both Leibniz's law and the claim that we have these diachronic identities, and to try and do some sort of fancy footwork to show how these are not contradictory after all. But we won't go into that now. That's all we've got really time for this week. And the question next week will be to sort of look at these attempts to reconcile the two principles, and look at the plausibility of these various ways of doing so. Okay, so the theory of temporal parts is next week's topic, and this is one particularly prominent attempt to reconcile cross-time identity with Leibniz's law. And so we'll be examining that in detail, as well as some rivals to it. So the key readings are given on the slide there. They're also given on Moodle. And in fact, PDFs of all of the readings, except for the low textbook for copyright reasons, are available on the Moodle course page. Okay, so that's it for this week. Hope you have a good week. I'll see some of you in seminars later in the week, and there'll be another lecture online in time for next week. Okay, thanks for listening.